Okay, guys, so we are back in the second lecture of May June 2009 paper 1 of AS Chemistry. All right, so now we are going to talk about MCQ number 11. Okay, MCQs number 1 to 10 have been covered in the previous lecture, and the link to that lecture has been given in the description, so do check that out if you haven't. All right. So now it's MCQ number 11. Okay, in some fireworks, there is a reaction between powdered aluminum and powdered barium nitrate in which heat is evolved and an unreactive gas is produced. What is the equation for this reaction? All right, so since it's barium nitrate, the unreactive gas that it could produce must be nitrogen. Okay, it's the nitrogen gas that it could produce, which because we know that nitrogen is highly unreactive due to its high bond energy and non-polar nature. So either C or D could be the answer. Okay, if you look at C or D, if we compare them, we know that it says that barium nitrate produces heat. Okay, how is heat produced? Okay, we can produce heat only if we the bonds are broken and made, right? And if it's an exothermic reaction. So if you look at barium nitrate over here and here, the barium nitrate in here in part C, it must have been decomposed to form aluminum oxide, barium oxide, and nitrogen gas. Okay, the nitrogen must have been liberated, whereas if you look at part D, the nitrate is still intact, it is not decomposed, so it cannot be D. The answer option, the best option is C, because the nitrate has to be decomposed to form nitrogen gas. Right, now MCQ number 12. Which gas or group of particles is in order of increasing size? All right, how to determine this? Well, we know from the periodic table that as you go up the group and across the period and diagonally, what happens? The atomic radii decrease. And so, all right, so this is what we know from the periodic table. All right, so let's take a look at the periodic table. Nitrogen, oxygen, fluorine are right over here at this end. So nitrogen, oxygen, and fluorine are at this end. Okay, nitrogen has the biggest atomic radius, followed by oxygen, and then fluorine. So again, this is cannot be the option. The first one cannot be the answer option. Then what about the second option? Nitride, oxide, and fluoride. The same trend will go apply to their anions as well, so it cannot be the option. What about the cations from sodium to aluminum? Again, from sodium to aluminum, the radius is decreasing, not increasing, because sodium has the largest radius because it's extremely to the left hand side, and then as we go from sodium to magnesium to aluminum, the atomic radius decreases. So this is not an answer option either, so only option that we are left with is delta, is D. Yeah, sodium, neon, and fluoride. Yep, atomic radius increases as we go across these three. Sodium has the smallest atomic ionic radius, sodium positive ion. Then if we go and look at anion, at neon, it has a larger radius because it is a noble gas. And then if we talk about the fluoride ion has even larger radius as compared to neon because it's to the left of neon. Right, so now so D is the best option. Then now let's look at the 13th option. Okay, river water is chalky agriculture area. Calcium contain this many ions. All right. In a waterworks, such water is treated by a calculated quantity of calcium hydroxide. All right, we add calcium hydroxide to it and we remove impurity. What will be precipitated following the addition of calcium hydroxide? Okay, for precipitation to occur, the salt that must be precipitated must be insoluble. This is what we know from theory part, right? Okay, so out of these, which ones are insoluble? We know that nitrates are all soluble and calcium chloride is also soluble, so the only one left is calcium carbonate. So B is the correct option. Now, foreign. Over 500,000 tons of bromine are manufactured annually and are mainly used for making other compounds. One important use is for agricultural chemicals. What is another important use of bromine? All right, this is theory part. You need to learn this. It is used in fire retardants and fire extinguishers. Okay, bromine. So C is the best option in here. Okay, 15. Black and white photographic films. Light converts silver chloride into metallic silver. Okay, after the film has been developed, the unreacted silver chloride is removed by reacting with sodium thiosulfate to produce a fixed negative. What is the function of thiosulfate? All right, so these are the answer options that are given. Let's look at the function. Okay, first of all, it says to make the silver ion soluble, and then says oxidize, oxidize, and reduce. All right, so for redox reaction, we must check out the oxidation number. Oxidation number of silver is +1, and if we check out the oxidation number in here, if we consider the sodium's oxidation state as X, so thiosulfate has a charge of -2 as indicated from its formula over here. So twice of -2 because two thiosulfate ions are there, and the whole thing has a charge of -3, whole and a complex ion. So is equals to -3, and so to the -4 goes there, becomes +4. +4 -3 is +1, so there is no change in oxidation state, so it's not a redox reaction at all with silver, with respect to silver. Not redox with silver. If not redox with silver, so cannot be oxidation, cannot be reduction. It's option A. Then cysteine, which statement is most likely to be true for astatine, and which is below iodine in group 7 of the periodic table. Okay, this is inorganic chemistry, again theory part. All right, so astatine is, since it is below iodine and it is near iodine, so it must show properties which are much most similar to iodine. Right, so now if we look at option A, astatine and aqueous potassium chloride react to form potassium acetate and chlorine. Actually, this reaction is not possible because iodine is less reactive than chlorine. So obviously, astatine is going to be even less reactive than iodine, because as we go down the group, the reactivity actually decreases rather than increasing. Then if you look at option B, potassium acetate and hot dilute sulfuric acid react to form white fumes of only hydrogen acetate. Okay, it does not form only fumes of hydrogen acetate, because as we know, if we react hydrogen iodide with H2SO4, the reaction that we get includes iodine, it includes sulfur dioxide, it includes hydrogen sulfide, it includes sulfur, it includes water. So hydrogen iodide is not the only thing that is formed when potassium acetate reacts with H2SO4, because potassium acetate forms hydrogen iodide first, but then it is decomposed, it is oxidized by the sulfuric acid because it is a very strong oxidizing agent. So this is not possible. Then the C part says that it reacts with aqueous ammonia in excess to form a solution of soluble complex. Actually, no, this is also not possible because iodine, when it reacts with excess ammonia, and silver iodide, when reacts with excess ammonia, it forms an insoluble complex. An insoluble complex, and this is again inorganic chemistry. And so the only answer option that we are left with is delta. And yes, this is correct, because when we reacted with hot concentrated sulfuric acid, it does form astatine. It should form astatine because when sodium iodide reacts with H2SO4, it forms iodine. So that's why this option D should be correct. Well, what about MCQ number 17? Deposits of ammonium compounds have been discovered in areas of high atmospheric pollution. They are believed to arise from the following reaction. What does not occur during this reaction? Or acid-base neutralization? Yes, it does occur because this is an acetic gas. This is a basic gas, forms a salt. Dative bond formation. We do have dative bond within the ammonium ion. Ammonium. This is the structure of ammonium ion, in which one dative bond and three covalent bonds are there, and this overall forms an ionic bond with the sulfate ion as well. So ionic bonds are also there, and the only option left is delta. Then option 18. Okay, more salt is a pale green crystalline solid. Okay, uh, what are the identities of the gas and the solid residue? Okay, it says that the identity of a second cation was determined by heating this with solid sodium hydroxide. Okay, sodium hydroxide is an alkali, and it is a property of ammonium salts. When ammonium salts are heated with alkalis, they liberate ammonia gas. Okay, so this gas that is evolved, it must be ammonia. Then it says that the gas readily dissolves in water to give alkaline solution, so it's confirmed that it's ammonia. Now it says that the gray-green solution solid residue was also formed when which was insoluble in water. All right, so gray-green residue being forming would mean that iron. This is actually a test for iron ions, iron 2 positive ions. When they react with aqueous ammonia, they form a green precipitate. That green precipitate is actually iron hydroxide. So the best options are option C. Then going on to option MCQ number 19. In recent years, a number of athletes have been banned from sports because of illegal testosterone, a naturally occurring hormone in the body. How many chiral centers are present in testosterone molecule? Well, chiral centers mean carbons containing four different atoms or groups of atoms attached to them. So if we look at the junctions that are not double bonded and that are asymmetrical, Those